There are lots of different kind of situations involving solving equations. So the first one I'm going to deal with would be, I think it's question 7 in my list. Let me check it. Yeah. You're essentially going to use Desmos to solve it graphically. In other words, you're not going to do any algebra. So if someone went and said to you, I want to solve, when is this equation, 7 cos x plus 5, when is it equal to cosine x minus 1? Now, the way they do that in question 7 is they call this guy f of x and they call this guy g of x. And when you want to find out when two things are equal, you basically want to find out the x coordinate of where they intersect. So if you want to solve an equation, make the left-hand side your first function, make the right-hand side your second function, put them in Desmos, and then just click on it, and Desmos will tell you, where they intersect. So in the question that we're going to do, that's this one here, they're only interested in the answers in the range -2 pi to 2 pi. And they even tell you what the y values are. And that's kind of helpful because sometimes Desmos gives you a really crunch scale and you don't, if you zoom out, you can't see it because it's too tiny, but if you zoom in, you can't see it because there's a bit missing. So let's do a Desmos. It should be a verb. Let's do a Desmos. So here it goes. So I'm just going to put the functions in right now. The first one was 7 cosine x's. And plus 5. And you can see what I'm saying. Look, it's the top bit's missing, but we'll fix that in a minute. And y is going to equal cosine x. Is that cosine x? I guess in my question it's cosine x. Take away 1. Let me just double check that question. Something sounds like I misread it.
Your cosine, that's it.
No, it's right. Okay, just looked wrong. Okay, so yeah, you're right. I've done something weird here. That's not what I was looking for. Okay, so you put whatever the first guy is, put whatever the second guy is. Now, even although this picture is really hard to see, if I kind of shrink it out a little bit, I'm really only interested in -2 pi to pi. So I want to make sure that I only get the answers that are correct for that range. So I'm going to do -2 pi to pi, to 2 pi. That was in the question. And I'm going to do, I'm also going to do the y values from -2.5 to 13.5, okay? So from -2.5 to 13.5. Click out, and it looks like there's really only 2 answers. You see there's one here, and there's one here. Oh. Well, there's my solutions. Negative pi, positive pi. Was that easy? Now, let's suppose it was 7, that guy, and this fella was x. So I'm trying to solve when is 7 cosine x plus 5 equal to x, and we're only interested in the range from there to there. Now, I don't have the bottom left-hand side, but I can tell that blue line's never going to meet the curve. So if I click on that guy, I get the answer 2.012, and I click on this one, you see the other answer would be 4.666. Someone told me that if you zoom in on this one, and I click on it, no, didn't work. Okay. Evidently, you can get more accuracy.
I've realized that only works.
Keep talking.
Sorry, I'm having issues. I realized that only works with certain values. It doesn't work every single time.
Huh. just Desmo's being weird. Right.
Yeah, it seems like it doesn't work if it would be like
Oh, here's an
1,
right.
2, and then some change, but if the change is too small, it doesn't show you what it is.
I'm going to try and do a 0, 0, 0, 0, 1 on the step thing. It might not work. I'm just doing it. See what happens. Nah. Okay. If that, hopefully that's the accuracy they want, in which case there's not a problem, right? But if you need to do 4 or 5 decimal places, can't you do the same thing on your calculator? It's just uglier, right? Because the calculator will do the same thing, but to about 8 decimal places. So that is one category of questions. I think there's 2 in the homework where you're just to do it graphically. And that's that. So let's now look at a different type of equation. And, oh, got this guy from yesterday. I also have my unit circle, my product to sum to product formula, and my double and half angle formula, because essentially that's what's going to happen today. So let me find a new guy to do. Let's do, for instance, question 8. And if the question, as it does in question 8, says use the addition and subtraction formula, then you go hunting for your addition and subtraction formula. Right. Which one's that? Right, it's this one here, right? And we are going to use it to solve sine of theta cosine of 3 theta. Oh, actually, it's not that one. Where is my addition and subtraction formula? Oh, I know the answer anyway, so it doesn't matter. Plus cosine of theta sine of 3 theta equals 0. Now, if I had the right formula, you would be able to look up a guy that looks like that. Do you know that that guy is the sine of A plus B, where A is that guy and B is that guy? So what you're going to be doing is the sine of theta plus 3 theta is 0. And so you're going to get the equation turns into that. So what originally looks like a really ugly equation is simply just solving when is the sine of 4 theta equals 0. And while we're at it, because we know we're going to use it anyway, what would the period of the sine of 4 theta be? What's the period of the sine of 4 theta?
Pi over 2.
Okay. 2 pi divided by 4, which is pi over 0.2. Why is that going to be important? Do you know when you do the 2 pi k thing? It's going to be pi over 2k thing, right? It's a period k, right? So we're going to use that later. Now, if the sine of 4 theta is 0, what angle in the unit circle has a sine of 0? Well, the angle that has a sine of 0 is this guy, right? Are we good? Which gives me, well, still gives me that. Is there anyone else in the unit circle that
Pi.
also has a sine of 0, pi? And so one of our answers is going to be pi upon 4. Now, if you want the general answers, won't it be theta plus the period times k, which is why we found this, and it's going to be, I should say 0, not theta. So it's going to be 0 plus pi upon 2k, which means it's just going to be pi upon 2k. So there's one of our general solutions. And the second one is going to be pi upon 4 plus the period. And if the question said, give me all the solutions, there they are. Now, if the question, as I think it does in this case, says, give us, how many do you want? Give us all the ones in the range 0 to 2 pi. Okay, I'll probably do this in a new piece of paper because it's getting a bit tight. I have theta equals 0. And then if I add a half pi, I get that. And if I add a half pi, I get that. If I add a half pi, I get that. And they don't want us to use 2 pi, so I'll stop there. If I do this guy, you get pi upon 4. And then you add a half pi to it. And if you add a half pi to it, and if you add a half pi to it, there are all the answers from 0 up to, but not including 2 pi. Are you comfortable about how you can use these just to generate all the answers, right? You've basically got 2 starting values, and then you just keep adding the period until it gets too big. I think I mentioned it yesterday. Nobody's told me whether it's that important, but when you're doing it in WebAssign, shouldn't you do in order? So you go this one, comma, that one, this one, comma, that one, this one, and so on, right, until you're finished. Are we good? Now, the thing that you needed to know was right at the start. You needed to know that this guy is the sine of A plus B. In fact, since I don't have that piece of paper because there's so many trig equations, I'll try and create them right now. There's 4 of them. The sine of A plus B is the sine of A cosine of B plus the cosine of A sine of B. The sine of A take away B is the sine of A cosine of B subtract cosine of A sine of B. The cosine of A plus B is the cosine of A cosine of B take away, I know that says add, but this is a take away, the sine of A sine of B. And last but not least, the cosine of A take away B is the cosine of A cosine of B plus the sine of A sine of B. Now, anybody who knows me knows I have an atrocious memory. But it is so much more convenient if you do memorize them. Because remember that first question, I couldn't find the formula, and I said, well, it doesn't matter, I know what the answer is anyway. Wouldn't that make my life so much easier because I knew it? Now, if you don't have that piece of paper, can you imagine in a test you're struggling to figure out where the heck you put it? You know, because you get 50 bits of paper and which one is it? So if you can, try and memorize as many of those little darlings as you can. Okay, so this is question 9. And I'm just going to set this one up. So we're not going to do the whole thing because it's very like question 8. When you look at this guy, he's one of these 4. So what you're looking at is the right-hand side, and you're trying to find which one has that kind of shape to it. And let me check I've written this down right. No, I've written it right. It's a cosine cosine plus a sine sine. Okay, which one is a cosine cosine plus a sine sine? Number 1, 2, 3, or 4?
4.
Okay, and this is going to be A and this is going to be B. So that means this is the cosine of A take away B equals 1/2. Now this has got a little kink in the tail because we're going to end up with the cosine of negative theta. We don't like negative angles in trig anytime. There are two, I think I've actually got it in another piece of paper, but there are two things, two little properties that are helpful. The cosine of negative theta is the same value as just the cosine of theta. Can you remember what the sine of negative theta is? I know it hasn't happened here, but maybe in another question it will. What is the sine of negative theta equal to?
Negative sine theta?
That's the one, right? I know I've done that somewhere, but here we go. So this guy now becomes the cosine of theta equals a half. Would you agree that's a pretty easy question to solve? Right, unit circle, do your stuff. Something different. Question 10 is asking us to solve the cosine of 2 theta equals cos squared theta, take away a half. And this time, they just want the general solution. Okay. So, can I find my piece of paper that we want to use? Here we are. You can't solve equations that have different numbers, right? You can't have a 2 theta here and a theta here, right? You have to try and change everybody. Okay. Now, the guy that's going to be changed every time that this happens is always going to be the cos 2 theta side, right? This one here. I have 3 different guys, right? So the cosine of 2 theta has 3 equivalent versions, but only one of those 3 works in this situation. Top one, middle one, bottom one. Which one should I use here?
The middle one.
Okay, correct. Why should you use the middle one? What's the clue?
You want to keep it in terms of cosine?
Right. So if this had said sine squared theta minus a half, wouldn't have used the third one, right? I guess there might be a situation, but it's hard to imagine the top one being used. So we've decided to go for 2 cos squared thetas, take away 1, is cos squared theta, take away a half. Okay, now we can start solving equations. As long as you do it to both sides, it's okay, Ro. Right, that's my go-to method. Tell me something to do to both sides that helps us get closer to solving this. What could I do to both sides?
Can you divide by the cosine squared theta?
You could, but I wouldn't do that. Only because I know what would happen. Something less.
Look at the numbers on one side.
Yeah, let's do the numbers on one side. So if you add 1 to both sides, okay. Think of it as 2x squared equals x squared plus a half. Yeah, do what you would do in that kind of situation. Okay, what do you think I should do to both sides? No.
Subtract the cosine squared.
And you get 1 left is a half. Can you see where this is going next? What should I do to both sides to find out what cosine of theta is?
Square root.
Right? And when you do a square root, isn't there going to be a plus or a minus going on, right? And I want to make that pretty because I'm going to use the unit circle. Nothing in the unit circle looks like that guy. So it's going to be the square root of 1 over the square root of 2, which is 1 over the square root of 2. Nothing in the unit circle looks like that either. But if I rationalize the denominator, do you see I get the answer plus or minus square root of 2 over 2? So they're really 2 different situations. I need to find out when the cosine of theta is equal to negative root 2 over 2. And I also need to find out when the cosine of theta is positive root 2 over 2. And I forgot to mention it, but I'll do it here. Isn't the period here going to be 2 pi? Right? So when we do our answer, isn't it going to be plus 2 pi k? Right? So let's solve this one. I want to find when is the cosine negative root 2 over 2. And that's typically going to happen in 2 places. So I have a 3/4 pi. And I have a 5/4 pi. And I also want to do when is it positive? And it's positive at 1/4 pi. And it's also positive at 7/4 pi. Are we good so far? No problems? Okay. Now, since the period, and I'm going to change this, but since the period is 2 pi, I get 2 pi k, I get 2 pi k, I get 2 pi k, and if I'd left enough room, I get a plus 2 pi k. Are you comfortable with these 4 answers? Right, the solution plus the period times k. Yet, the answer that I'm going to get is only going to be, let's get these 2 guys right. So here's my question. How did these 4 guys end up being equivalent to just these 2 guys? How can these 4 fellas be the exact same as these 2 fellas?
You're going in
Pi
Let me
over
see.
4 equals 5 pi over 4.
Right. So if you take this guy and add a pi, you get this one. And if you take this guy, you get that one, right? Essentially. So these are correct. But these are correct like it's 2/4. And these are better correct because it's like 2/4 become a half. Sometimes you will find that your solutions are inside each other, right? So if you do a different way of looking at them. Another way of figuring out why there's only 2 is, at this point here, isn't the period 2 pi? What was the period of this guy at the beginning? What's the period of the cosine of 2 theta?
Pi.
And that is indirectly causing that. Right. So, a little hiccup. Oh, next one. Different situation again. The cosine of 3 theta, take away the cosine of 5 theta equals 0. And they even tell us to use the sum to product formula. And that one I have never bothered to memorize because it's, well, it's hard to memorize and it's not used that often. So the sum to product are these 4 guys down here. I have a cosine, take away cosine. So think of that as being my A and think of that as being my B. So I'm looking for a cosine, take away a cosine, which means it's this bottom one. See it? Cosine, take away cosine. So it's going to be a negative, and yeah, it is a negative, 2 times the sine of A plus B over 2 times the sine of A take away B over 2, still equal to 0. Now, if you take these 2 and you add them, you're going to get 3 theta, add 5 theta, and then you have it, times the sine of 3 theta, take away 5 theta over 2, and that is 0. And this guy gets you 4 theta. And this guy gets you negative theta. Right, we do not like negatives. What will I turn the sine of negative theta into then, so it's not a negative inside the angle? What's the sine of negative theta the same as?
Negative sign.
So those two cancel out because you've already got a negative, and we are looking at that guy. Looking good? Now, this is going to be another one of those situations where you may have lots of answers, but they all kind of end up inside each other. And so you can shrink them into a much smaller looking answer. And we're looking at the general solutions here. So 4 theta is equal to 0. And 4 theta could also be pi, right? That's the 2 places on the unit circle. This becomes 0. And this becomes pi upon 4. What is the period of pi upon 4? Sorry, what is the, I think, rewind that question. What is the period of sine 4 theta? That's what I'm trying to say. What is
Pi
the
over
period?
2.
Right, pi over 2. So technically, pi over 2k plus pi over 2k. Now let's look at these two guys for a minute. Is either of those inside the other? In other words, if you did all of these, you'd get that. If you did all of these, you'd get that.
Yes.
Okay, so if you want to keep one, why don't, that's a pi upon, what is that, 4? 2 theta? Pi upon 2, my apologies. Pi upon 2, so you could keep one, right? Something's not right.
I
Okay,
don't think they are inside of each other.
no, they're not. You're right. That's what's not right. Okay, so I've got two answers. I've got pi upon 2k, and I have that one. Okay. I'm looking at the answer. According to them, something's inside, so I'm not quite sure what yet. If you do sine of theta, don't you get theta is 0 and theta is pi? Oh, well, these two guys, aren't they definitely inside this one? If you make k 0, you get that. And if you make k 2, you'll get that. So these two solutions came out of here. So I definitely know that I can do that solution. And I don't know why they don't have that one. Still don't know why they don't have that one. Oh, I know how they did it. Yeah. Okay, here goes. Theta is pi upon 2k, and theta is pi upon 4 plus pi upon 2k. This guy is 2 lots of pi upon 4k. So couldn't this one just be thought of as some multiple of pi upon 4k? Right, you've got 1 here, you've got 2k here, you're still going to get a number. Don't like it, but that's their answer. I think that's a better answer. But evidently, they don't. They think that's the answer. Don't like answers like that. They don't agree. Okay, 13 we've done. 14. Oh, we're back to the boring ones. Okay, do it anyway since I started. Okay, we want to solve this guy. At least we don't have any horrible algebra to do. But it's not a very interesting question, in my opinion.
Is pi
So-
upon 4k the whole answer?
Yeah, that's it. I don't like it as an answer,
That's
but
like the
that's
one
it.
solution.
The one solution that has everybody inside it. If you take pi upon 4 and you multiply it by 1, 2, 3, 4, 5, 6, 7, 8, 9, all the other solutions that we talked about are inside that one. Right. That's what they were saying. Okay, since this one is a little bit more obvious, I hope. What is going to be the period of this guy? And be careful. What is the period of tan 3 theta?
Pi over 3?
Correct. For a tangent, isn't it pi over the number, not 2 pi over the number, right? So you want to solve this guy. You are simply just going to divide by the square root of 3. And we should be able to find the answer by taking the y coordinate and dividing them by the x and getting this guy. And basically, if you cover these two guys up, do you get 1 over root 3? Agreed? So that is pi over 6. So that makes theta pi over 18. Are we good? Right. Now, is there anywhere else where you could get that same answer? Is there anywhere else on the unit circle? where
At
if you took
240?
Okay, let's cover that up. Is that the right way around?
No, it's
So,
not.
but if we move up, it's to there.
Yeah.
But you were down
yes.
close, right? So what we're looking at here is 7/6 pi, which means 3 is 17/18 pi. Now, if you were doing the general solution, you would do pi upon 3k, and you do pi upon 3k. These two can be combined into a single guy.
Wouldn't it just be pi over 18? Oh,
You're darn close. They are doing the 5/18 version. Now, if you take 5/18 and add on pi upon 3, let me try and make it a little bit clearer, because it is kind of like mud here. If you make that into 18s, you get 16/18 pi. And if you take this guy and you add and subtract multiples of it, allegedly, you will get one of these families. That is a really ugly question. It looks simple until they merge them. So that is your solution.
I am very confused on how that's solution.
Yeah.
It
Right,
doesn't make sense on how that's the solution.
Yeah. Let me do something to try and make it a little bit clearer. I'm going to turn that pi upon 3 into 6/18 pi. Right. So the first answer is pi over 18. The next answer would be add 6 to that. And the next answer would be add 6 to that. Right. And then you could keep going forever. Now the other solution was what, 7/18.
Why is it not just pi upon 18 instead of 5 pi upon 18? Because pi upon 18 plus pi over 3 is 7 pi over 18, which gets you your second answer. So how'd you get the 5?
No, but I'm still in the process of thinking, so I'm about to, I guess, find out. Right, if we take the second one, which is this guy, and you add, what's that guy? You add 6/18 pi. You add 6 to that guy, you get 13/18 pi. You add 6 to that guy, and you would get 19/18 pi. First thing, do you notice that these guys are already included in this one? Would you agree? And so this one, is that the one you're saying, why don't we use that one?
Correct.
Yeah. And my answer to you is, don't know. I think that's a valid answer. So they say it's pi k over 3. No, they don't. They say it's 5/18 pi plus that guy. Okay, so they're saying it's 5/18 pi plus 16/18 pi. So I guess the only argument we've got is, what's the difference between this one and this one? And the difference
Isn't it
is,
4/18?
no, the difference is, it's not their question. I'm looking at a different version. Their version has that guy. So our answer is exactly what you said it should have been. It's that one. The question that I should have been doing, which had the answer I said it was that one. The question I did is this one. For this question, the correct answer is exactly what we decided it should be. Right. And their answer, which is the other one, they use that guy. So it does work, in fact. So, for the question I did, right, the one we did, this is the right answer. For the question they've got in the book, this is the right answer. Right, I'm going to have to do another one of this. Let's make one up. Let's suppose I do square root of 2, the tan of 2 theta equals 1. Now, I know the period in this question is going to be pi over 2. So we're going to get that guy. I'll make that square root of 2. That is better. So we're going to get tan of 2 theta is equal to 1. I'll go to my unit circle. And if I find what angle has a tangent of 1, one of my answers is pi upon 4. And that gets me pi upon 8 plus the period k. If I look for another answer where that is also true, I get way down here, I get 5/4 pi, and that gets me theta is 5/8 pi plus pi upon 2k. Are we comfortable with those two solutions? Right. That solution, now that one. Now I'm going to convince you, I hope, that that one contains all of these. If you write it down as pi over 8 plus 4/8 pi k, what do you get? Well, the first answer you get is pi over 8. The next one you get is 5/8 pi. And the next one after that is 9/8 pi, whatever. If you take this guy here, right, the 5/8 one, and you add this, the first answer you get is 5/8 pi, which is actually here. The next one you'd get is add a half pi, which is 9/8 pi. Do you see it's already here? And all these solutions already inside these solutions. And therefore, that's the only one you need to write down. Does that make it a little bit clearer what should have happened in the earlier question before I kind of got lost? Okay. I guess the moral of that story is the ones that look easy don't always end up being easy. So we've got to do something to finish with. So let's do 17. And I'll try and squeeze in 18 if we have time. So in question 17, we're trying to solve the sine of 2 theta plus the sine of theta equals 0. Anybody got suggestions about either of those two that should be changed and what they should be changed into? Because you can't have 2 thetas and thetas like this. And the answer is going to come from here somewhere.
Make sine 2 theta, 2 sine cosine theta, and then factor out sine.
That's it. Now, I won't be able to do all of this only because of time. And so when you get a sine of theta is 0, and eventually a cosine of theta equals -1/2, right? And in this question, they don't want the general answer. They just want to know all the answers between 0 and 2 pi, but don't include 2 pi. So that's a little bit easier. Don't you just have to write them down until they get too big? Right. Now, 18 then has got the tan of 1/2 theta take away sine theta equals 0. If you look through this formula, which of the ones am I going to use now?
Tan of half theta equals
One of these two guys, right?
yeah.
Yeah. I don't know which one's the best one, so I'm just going to pick this one and hope that it comes out good. And it will. Well, there's going to be a lot more math involved in this one than there was in 17, because right now we have a lot of issues. We've got a fraction, don't like them. We've got sines and cosines, don't like them. So I'm going to add sine theta to both sides. And I'm going to do a little cross multiply. And that's going to get me sine squared theta is 1 take away cosine theta. Now we've done questions like that today. I've got a sine squared and I've got a cos theta. Don't I have to turn the sine squared into things that look like cosines? And the guy that does that is called 1 minus cos squared theta. Okay, we're getting closer. What should I do next?
I have a question.
Yes,
How come you don't just divide out the sine
divide out the
or
sines.
multiply sine?
On both sides? Well,
Yeah.
okay, so I'd get 1 minus cosine theta. Take away sine squared theta is 0. And you'd end up with the exact same answer.
Okay.
A different approach. Right, what are we going to do now? So long as you do it to both sides, it's okay. What are we going to do now? Think quadratics. What should we do?
move everything to one side.
Okay, so I'm going to subtract 1 from both sides, which is kind of nice because they kill each other off. And I'm going to add a cos squared there. Now I'm going to write this guy slightly different order, but it's essentially the same thing. Right, we're darn close to doing it. You just have to know what you're looking at and what you can turn it into. I'm looking at a cos squared, take away a cosine, right? Equal to 0. Does anything come to mind what you might do here?
You could probably factor out the cosine.
You should. And that means we only need to now find out when the cosine is 0 and when the cosine is equal to 1. And this is another one of those questions where they're only interested in the answers between 0 to 2 pi, so you don't need to worry about general formula, right? So the original question, which is this equation, ended up with quite a lot of work becoming this equation. Now you know how to solve those and you are good. And I believe that's perfect timing because that is our last question. So last name and bye-bye. And Monday is a holiday and homework and the test, the online test, are now due, both of them, midnight Monday. So I won't see you until Tuesday. Bye-bye. Hope I didn't distract you too much with that tan one.
All right. Have a good weekend.
You too.